couple of weeks ago, my younger brother Mike had asked a question about how cartridges avoid the electrostatic discharge issue, or ESD, when inserting and removing a card. He had been reading a book about the history of Atari, and they had mentioned that someone had come up with a solution. I think it was Fairchild came up with a solution for avoiding electrostatic discharge when inserting and removing electronics, and it's a common problem in the industry. The solution was found a long time ago, back in the 70s, but I wanted to show quickly how electrostatic discharge is avoided when inserting a card. Because whenever you have two pieces of plastic that rub against each other, you'll build up a static charge. And of course, when you're inserting a cartridge into a game system, you can be generating some static charge, and as you insert it, if it goes through the sensitive electronics, you've just blown up a cartridge. Well, you can notice you can remove and you can swap cartridges all day long and not damage the cartridges. So how do they do that? Well, the most simple solution, the most elegant solution, which has been done for a long time, is, here's my beautiful copy of Dirty Larry Renegade Cop. But you can see here, you'll notice that these pins on the end here, and this pin here, are longer than the rest of the pins. These are almost certainly the ground and power pins for the chip that's embedded in here, and the rest are the data lines. So you can see these pins are longer. So what happens is when you insert the cartridge, these pins hit first and discharge the static electricity, and then the data lines get connected. So that's a very elegant solution. It's very common. You can see this cartridge is for Atari Lynx. It was designed over 30 years ago, and you can see even in more modern systems, this is a Game Boy, this is a DS, I believe, cartridge, and you can see the exact same solution. You can see this pin on the end here, that pin there, are longer than the data lines. So as you insert the cartridge, the exact same thing happens. It discharges along those pins first and just grounds it out, so the sensitive data pins don't get zapped. And even something as new as a, say, SD card, you notice all the pins, all the pads are about the same length, but if you look at the socket, you notice these are significantly longer than the rest of the wiping arms here. So as you insert the SD card, that SD card makes contact with these three pins first, discharging it. So when you slide it all the way home, you lost your static charge has been dissipated into the ground plane. Now, and even something as modern as this is a USB 3, probably impossible to see. You'll probably take my word for it. But the outer two pins are longer on the USB, and that's your power and ground. Those are the outer pins. The two center ones are the data lines. So as you insert your USB, plus the outer casing is grounded too, but as you insert it, it's discharged first. But you'll notice sometimes, this is the older Game Boy cartridge. This is a regular Game Boy Advance. All the pin lengths are actually the same. So what you do is you look inside, and it's hard to see, but the pin all the way to the right is a good 100,000th of an inch further out towards me than the rest of the pins. So as you inserted the cartridge, that last pin will hit first, discharge static, not blow up your electronics. So in case everyone's wondering, how the heck do they keep from zapping your electronics? It's a simple solution. Just make one pin longer than the rest, or several pins longer than the rest, and discharge through that path, and you have working electronics. It's a solution that's found probably about 40 years ago. Works back then, still works now. So, thanks for watching.